Okay, welcome back everyone. So in this video, we will talk about the numerical integration. So numerical integration means suppose I want to find out a to b f of x dx, that too numerically. Now before going into the details of numerical integration, first understand the polynomial representation. So suppose I have data points, let's say this is x and y. This is just like regression, polynomial regression, or I would say linear regression, which we understood, or non-linear regression, whatever we call it. So suppose I have data points which are given in this form. Now using these data points, I want to make a polynomial function out of it, and that polynomial function is given as a plus bx plus cx square. Now there might be 3 points, so this number of points should be greater than or equal to 3, because here we are doing a linear regression or polynomial representation of second degree. So there are 3 constants a, b, comma c. So at least we require 3 points to get the value of this abc. So how will we get the value of this abc is, so suppose in one case, let's say case a, where n is equal to 3, where the number of point is 3 only. So what we will have, and the 3 is given as x1 y1 x2 y2 x3 y3. So how will we get the value of a and b? So what we have, y1 is a plus b x1 plus c x1 square, y2 is a plus b x2 c x2 square, y3 is a plus b x3 plus c x3 square. So how we can write it? We can write it as 1 x1 x1 square, 1 x2 x2 square, 1 x3 x3 square, a b c, and this is y1 y2 y3. So we can directly invert this matrix and we can find out the a b c vector. The second case is when when n is greater than 3. So in that case, this matrix, so we will have x1 y1 x2 y2 up to xn yn. So in that case, what we will have, 1 x1 x1 square, 1 x2 x2 square, going from 1 xn square, and then we will have a b and c, and then we will have y1 y2 going up to yn. So remember, this is not a square matrix, so we will not be able to do the inverse of this matrix. So before doing that, suppose this is my system matrix ax is equal to b. Now how will we solve this? When matrix A is not square matrix, so we will first multiply it with A transpose, and then this matrix is square matrix. Now we will invert it, so the x will become A transpose A inverse A transpose B. So this is my square matrix. So this is how we can represent any number of points in a form of a polynomial. Now let us go to numerical integration. So numerical integration means that we have a function f of x, and that has a very complicated form. Suppose this is having 1 upon 5 plus root of exp sin x. Now this function is very complicated, you know. It is very difficult to find out the integration of f of x dx between a and b. So what we will do, we will, this f of x is y, so what we will do, first we will try to generate the data points x and then corresponding y. We'll put the value of, you know, this is my a and this is my b, and we'll put value of a, then we'll generate y, again we will put the value of x, and this is how we will generate the data points. So put the value of x, that is between a and b, and find out the value of f of x, that will give me y. So this is how I will have the data points. Now what I will do, or another situation can be that from an experiment I directly have the data points x and y, a and b. So two kinds of scenario exists. So suppose either from the functional form or from the experiment I have the data points that are given to me in this way. So this is my y and this is my x. So what I will do, a, b. So I will divide this range in segments. The number of segments depends upon me, that how much accuracy I want, and within each segment I will try to make the polynomial representation of this function approximated. So using these data points I will calculate in this interval a1, b1, c1, a2, b2, c2, a3, b3, c3, a4, b4, c4, a5, b5, c5, and within each this interval I will calculate the value of, you know, a2, this is x1, this is x2, this is x3, this is x4, a2 x1, a1 plus b1 x plus c1 x square dx, where I know the value of a, b and c, and that is my a1, x1 to x2, a2 plus b2 x plus c2 x square dx is equal to a2. Like this I will solve x4 to b, a5 plus b5x plus c5 x square dx is equal to a5, and I will sum these, and this will give me a total area. This is an approximated area, so this is numerically calculated area. So this is how basically we will do the numerical integration. So how this is important, suppose we want to calculate the area under the curve, but the function has a very complicated form and it is very difficult to do the integral of that function. So in that case what we can do the numerical integration, and to do the numerical integration first we need to generate the data points. So we will basically divide that range into small segments, and we will insert the value of x and find out the value of y. So this is how we will generate the set of data points x and y. Now based on the, you know, order of accuracy I want, I can do the first order polynomial representation, I can do the second order polynomial representation. So in this case what we have done the second order polynomial representation. So we can do the second order polynomial representation, we can do any order and any order polynomial representation. So we will see that how rules are, you know, made based on this order of polynomial representation. So this is how, you know, we can calculate the area of each segment, because the direct integration of this polynomial function is very easy. So we can directly integrate it and find out the value of a1, a2 up to a5, and then add them up to get the total area of the curve. So in the next video we will talk about the various, you know, methods which have come out for the numerical integration based on the order of polynomial.